Now, what are the circuit diagrams? Now, in the circuit diagrams, what you have is you make use of the circuit symbols. Now, these are the circuit symbols which are there in your syllabus, and you should be able to know how to draw them. And if the circuit symbol is given to you, you should be able to spot what it is for. So if there is a circle and a line, that's an open switch. When you join that, that's a closed switch. One big dash and a small dash is a cell. And when you have more than two dashes like this, that becomes a battery. A diode is a device that conducts electricity only in one direction, as it has a high resistance in the reverse direction. So you show it with a circle and a triangle and a bar on the top. Resistor is a normal block. When on the resistor, you have this arrow going, that becomes a variable resistor. And when on the resistor, you have something like a graph going up, that's a thermistor. Thermistor is that resistor whose resistance depends on temperature. Variable resistor is that resistor whose resistance keeps on changing. A circle and this across is a bulb. A fuse is a device which breaks the circuit when a current greater than the threshold is passed on to it. So it's a box with a line in the middle. Then if on a resistor you draw arrows coming down, that's a light dependent resistor whose resistance depends on light. A circle and an A is an ammeter, which is a device that is used to measure the current in a circuit. And V is a voltmeter that is used to measure the potential difference in a circuit. And then if you put a triangle and an arrow going up, that is a light emitting diode. Okay, so I hope these circuit symbols are clear to you. And in physics, to draw the circuit diagrams, we make use of the circuit symbol. So let's take one example. So you need to draw a circuit diagram with a battery, bulb, and a switch. And for this circuit, you need to measure a current and a potential difference. So I hope you remember for the current, we use a device called ammeter. And you need to remember that ammeter is always connected in next to the battery or the bulb. That is, it is always connected in series. And voltmeter will be connected parallel to the bulb. So what we will do is, this is the switch, then this is the battery, then this is a bulb. The voltmeter is connected in parallel and ammeter is connected next to it in this series. Okay, so I hope this diagram is crystal clear to you. And always remember, ammeter in series and voltmeter in parallel. That is very, very important. Now let us look at the very important triangles or the formulas that you need to remember. Time, the unit of current is amperes, charge is in coulombs, times is in second. So 1 ampere is 1 coulomb per second. So current is a rate of flow of charge measured in amperes. 1 ampere is the current flowing when 1 coulomb of the charge flows to 1 second. The second is the voltage, the resistance, sorry. Resistance is voltage divided by current. So resistance is the obstruction to the flow of current, which is measured in ohms. And the last definition is potential difference, which most of the students forget. So please make sure you remember that. Potential difference is work done per unit charge. So potential difference is measured in volts, work done is measured in joules, and charge is measured in coulombs. So 1 volt is 1 joule per coulomb. So 1 volt is the potential difference when 1 joule of energy is transferred per coulomb of charge. Okay, so I hope this definitions of current, potential difference, and resistance is clear to you. Now let us look at few questions that can be asked related to these triangle. First is calculate the current flowing when 4 coulombs of charge flows for 2 minutes. Now you need to take care of the units. The units have to be in seconds. So current is charge over time. Charge is 4 coulombs. Times is 2 minutes. So times by 60 is 120 seconds. So the answer would be 0.033 amps. Calculate the energy transfer when 2 volts of potential difference create a charge of 2 coulomb. So energy is voltage per unit voltage times the charge. Our voltage is 2. The charge is 2 coulombs, so the answer is 4 joules. Next is you need to calculate the resistance when potential difference is 4 and current is 2. So V over I gives 2 ohms. Next is charge when 5 amp current flows for 5 minutes. Again, we need to convert 5 minutes into seconds, and charge is current times time. So that becomes 5 times 5 times 60, which is 1500 coulombs. And then calculate the potential difference when 10 joule of work is done to move the charge of 5 coulomb. So remember, I told you potential difference is energy per unit charge. Energy is 10 joule, charge is 5 coulomb, so that is 2 volts. Okay, so I hope these examples, how you need to use these triangles, is crystal clear to you. Make sure you remember the triangles along with the units. Okay, All right, now this is a very important part. You need to draw voltage time current of any conductor or a resistor, a filament lamp, and a diode. Okay, now when we talk about a conductor, in a conductor, as the voltage increases, the current increases, there's a linear relationship. Okay, provided the temperature has to remain constant, and this is also known as Ohm's law. Now, for the filament lamp, it shows a linear relationship at the start, but after that, with further increase in voltage, the graph curves up like this. Okay, so as the voltage increases, the current increases at the start, but after the bulb gets heated, an increase in temperature increases the resistance, so the current do not increase as much with the increase in voltage, and the graph curves. So at this point, there's an increase in temperature, increasing the resistance, making the graph curve, as opposed to a conductor where there's a linear relationship. Okay, so I hope you are clear with this shape and how you need to explain this shape. Next is a diode. Remember, diode conducts electricity in one direction. So there's a flat line in the reverse direction, and diode needs a certain threshold voltage, and then it starts to conduct the current. So this point is your threshold voltage. So diode conduct electricity in one direction. In reverse direction, the resistance is too high, so no current flows. When it reaches a threshold voltage, the current starts to increase, and then it becomes a linear relationship. Okay, so I hope these voltage current graphs are clear to you. You should be able to sketch them in the exam and explain these shapes. Okay, so now we need to do a series circuit and a parallel circuit. In the series, the resistance are connected next to each other. In a parallel circuit, they connected parallel. The total resistance in a series circuit is the sum of the individual resistance, which is greater than the individual resistance. So R1 plus R2 is R total. The current across each component will be V over R. So total voltage over the total resistance, which is the sum of R1 plus R2, gives the current in across each component. And remember, in series, the current is always the same. So now you got the current by this formula. You can do I times R1 for the voltage across R1 and I times R2 for the voltage across R2. And that will give you the voltage across each component, because the voltage gets divided according to the resistance. Now, in a parallel circuit, the total resistance is less than the individual, and the formula is R1 R2 divided by R1 plus R2. The voltage will remain constant across each, so the current will get divided, and current will be the total voltage divided by R1. The current across 2 is the voltage across R2. Okay, I hope these formulas are clear to you. Remember, in a series, the current is same. In the parallel, the potential difference is same. Now, let's take an example. So these two resistance are given to you, 5 and 10 ohms with 20 volts. It's a series circuit. It's a parallel circuit. So total resistance in case 1 will be 15 ohms. The sum of this. The voltage is 20 volts. So the current flowing across each component will be voltage over resistance. So 20 over 15 is 1.33. So we have 1.33 amps flowing across each resistor. Now we know potential is current times resistance. So we'll do 1.33 times the resistance of each, and we'll find the current flowing across each. Okay. So that is the voltage across each. So that is 6.7 and 13.3. Now in a parallel circuit, the total resistance is R1, R2 over R1 plus R2. That gives us 3.33. The total current is total voltage divided by total resistance, which is 6 amps. So 6 amps is the total current. The voltage will be 20 volts across each component. So we have the voltage and the resistance across each. So current is voltage over the resistance. So 20 over 5 is the 4 amps across the current across 5 ohms, and across 10 ohms it is 2. And we'll add them. That will add up to the total current of 6 amp. Okay. So I hope how you do the calculation with series and parallel circuits is clear to you. Next is the UK's main supply. If you talk about the UK's main supply, you need to remember there's a 230 voltage and the frequency is 50 hertz. This is a 3-pin plug, which we see in all our home socket. You need to know the components of each. Okay. So can you see there are 3 wires? One is blue in color, one is greenish yellow, one is brown color. The brown color wire is a live wire where the main current flows, and the fuse is connected just to the live wire, because if the current exceeds a threshold in the live wire, it breaks the circuit. Then you can see to the other side, to the left side, goes a blue wire, that is neutral wire, in which no current flows. And to a top pin, there's a greenish yellow wire, and this is the earth wire. which earth is the electric current. And then there's a cable grip, which is made up of an insulated material called plastic, and it keeps all the wires in place and prevent them from touching. All the pins are made up of brass, and you need to remember that they're made up of brass, as it's a good conductor, and being an alloy, it's resistant to corrosion. So rather than making the pins for copper, we make it for brass. On the other hand, the wires are made up of copper, as they are good conductors of electricity. So you should be able to label all these wires, remember the colors and the function of each wire. Now, there's another important triangle called power. Power is measured in watts, which is energy per unit time. And when we talk about electrical power, that can be measured by either voltage times current, and V can be written as IR according to the resistance triangle. So another formula would be current square times R, or I can be written as V over R. So another formula is P equals V square over R. Okay, so you need to remember all these three formulas, and in the exam, they can give you either voltage or current or resistance and current and ask you to find the power. Let's take an example. You have to calculate the current produced by 200 volt bulb if generates a voltage of 10 volts. Okay, so what is the formula of power? Power is current times voltage. So what is our power? Our power is 200 watts. Our current we have to find, so we divide it by voltage, so the power will be 20 watts. Next is, what is the best fuse for this appliance? Now, what is the current that is flowing in this? The current is flowing is 20 amps. So the fuse should be greater than that. So 23 amps will be the useful fuse for this. Okay. Next is, there are two types of current, direct and electric current. Direct current flows in one direction. You can see the graph is just a straight line. It is a current in cells and batteries. The alternating current, the current switches on the direction, and this is what is there in the main supply. Now, what is a national grid? A national grid is a network of tables and transformers that transmits electricity from a power station to homes and buildings. So this is a generating station, and you can see that we have used a step-up transformer to increase the voltage to a very high level. Why? Because at a very high voltage, the current reduces, and the current has a lot of heating effects, and that results in the loss of energy. So when you increase the voltage, you reduces the current, and that prevents the loss of energy due to heating effect of current. But as soon as it needs to go to the customer or to the homes or the offices, we use a step down transformers that decreases the voltage to 230 volts. Is that what we require? So you should know why we use the step up transformer and step down transformer. Where do we use it? And what is the function of this? Okay, so now let's do the last point. What is a static electricity? Electricity that is produced by rubbing. Because when we rub two objects, there's a transfer of electrons from one surface to another. The surface that loses an electron, it becomes positively charged. And the surface that gains an electron becomes a negatively charged. Okay, and there's an electrostatic attraction if both charges are same. And there's a repulsion if the charges are different. So you can see here, these are two positives. They are repelling each other, and if there's a negative and a positive, they are attracting each other. So like charges repel and unlike charges attract each other. Okay, so I hope you know how the static electricity is produced. Now, electric field is a line which always travels from positive to negative. Across any charge object, there is a certain area where you can feel the force of the electricity, and that is known as an electric field. You should be able to draw these fields of lines. If there's a positive charge, they'll be directing away from positive and directing towards the negative, and they always flows from positive to negative. Okay, I hope this topic is clear to you. Now let us look at what are the key terms we saw in this topic. What's a current, charge, thermistor, resistor, cell and a battery, variable resistor, thermistor, diode, ammeter, voltmeter, potential difference, resistance, direct current, alternating current, live wire, earth wire, neutral wire, fuse, power and efficiency. You can pause this video, have a go over these key terms, okay, and then come back and check the answers. All these key terms definitions you can find on my website. The link is mentioned in the description box below. Now it's the time to test yourself, okay? So pause your video and try these questions. You need to sketch and explain the voltage and the current graph of a resistor, filament lamp and a diode. What are the components of a 3-pin clamp? What is the voltage and frequency of UK main supply, and how do you calculate the efficiency of an appliance? All right, pause the video, have a go, and let's check your answers now. So this is a voltage current graph, linear relationship for a conductor, filament lamp, it will be curving, diode will be a straight line, and then it will be going up. Okay, and you should be able to explain it as here there's an increase in temperature increasing the resistance. Diode conduct electricity only in one direction and after the threshold is reached. Next is the main electricity. These are the components: earth wire, live wire, neutral wire, and fuse, and you should know the color and the function. And the UK main supply is 230 volts and 50 hertz. And to calculate the efficiency, we do the output power over input power times 100. Okay, as always, what's the next step? Check the specification, make sure everything which is there in the specification is clear to you, and do exam questions on this topic, which you can find on my website. The link is shared with you in the description box below. If you like this video, then do subscribe to our channel, and do not forget to click the bell icon, because you will get notified as soon as I put a new video if you click on the bell icon. Okay, so if you need more notes on this topic and exam question, come to my website. The link is mentioned in the description box below. If you do like this video, do let me know. How do you find it? And also, if there's any specific topic you want me to make the video on, leave a comment below and I'll make sure I'll make it before your exam. So I'll see you next in the next video. Till then, happy revising!